Now we will start with the definition of the seismic load. Go to define, mass source, modify, dead load, add live load is 0.25 as per IS 1893. Lumped mass model adjust diaphragm central. This will specify load patterns. Okay. Now define load patterns. Here we will take it as SEISMIC seismic type, seismic 1893 2016. Add new load, modify lateral load. We can take it both along x as well as y direction. As we have said earlier, the building is said to be constructed in zone 2. Therefore, the value of z according to IS 1893 would be 0.1 as it falls along in zone 2. In zone 2, soil type is based on the hardness of the strata, considered as a medium soil. Importance factor based on its occupancy, and take it as 1. The response here, take the time period program calculated, as it automatically considered all the dimensions of the buildings and accurately calculate the time period of the structure. Then response reductions factor, it depends on the frame. There is reductivity, that is, in this case we have ordinary moment resisting frames, hence the value of R comes to 3. Then OK. You have to go for define load combinations. You have these many. Add default combo, concrete frame design. Then OK. Then analyze, set load cases to run. In this case we can keep this one as run do not run. Then OK, go for analysis. And basically it is a equivalent static method. Okay, these are the displacements due to the. You can go for design, concrete frame design. You can check view revise, its size 456. Done. Design, concrete frame design, and start design check. Then go to design, concrete frame design, verify all members passed. Here the concrete design is complete. Now we shall start with assigning a response spectrum method. Now we can go for response spectrum method. First we need to go for define load patterns. Here modify lateral load both along X. Note down the parameter, that is 0.1, 2, 3. Okay, cancel. Okay, first unlock the model. Next, define. First we need to define the response spectrum function. So go for response spectrum, click here as IS893 2016. We can modify show UNRFFC, that is we can, otherwise just delete the spectrum, add new function 1893. Okay, RE or 1893. Here for concrete 5% of damping ratio, seismic zone is 2, that is 0.1, importance factor is 1 which we have given, soil type is again 2, then R value is taken as 3 which we had taken before. This is the graph which we get, that is response function. Okay, then go to define load cases. We need to add new case as response spectrum. Response spectrum, load case type as again response spectrum, load type add, acceleration, load name U1, function is 1893. This one, to do this one, first we need to check the units. Okay, units of acceleration, in which it is, sorry it's velocity, both are in mm per second square and mm per second square. Okay, then it will be like 9801. So remember this value 9801. Define load cases, add new case, response spectrum. This is again response spectrum, add 1893. This in this table we need to input a formula, the values which we get from a formula Ig/2R, where I is the importance factor which is 1 and G value is 9801 and divided by 2R. R is the value, R we have taken as 3. So by calculation we get 1663.5. So input that value, add, go for the other direction, function is 1893 again, and we get the same value 1663.5. everything remains the same. Diaphragm eccentricity is taken automatically for this thing, 0.5 modal damping and other things. Okay, SRSS or CQC, response spectrum. Okay, so we can go for also we can, after defining all these things, we can go for run analysis and check the behavior of the structure, and then we can design it. After analysis is completed, the whole part will be divided in seismic as well as for, okay, this is spectrum values. Okay, okay, we get the displacement values due to dead load and other things. Then design, concrete frame design. Now if we view revise preferences, design, concrete frame design, start design check. It takes time to run the analysis. As well as to design. Okay, you can see here, go to design, concrete frame design, and verify all members passed, hence we get a design. Okay, if we go for reports, you can get a project report which is generated automatically by the e-tabs, as well as we can get a summary report which will give you a brief information about the ongoing project. Now, as a response spectrum method is complete, we can go for time history method. Okay, first unlock the model, then define load patterns in seismic. Modify lateral load, we keep it in only one direction, rather whole part remains the same, we keep it in the same. Okay, now define functions. We need to define a time history function here. So we are taking from a time history that has history of an earthquake which has taken place in Bhuj. Okay, so I have that data. Okay, add new function. This is called as time history. Now browse the file. I have it on my desktop. Okay, here it is, example time history data, open. Okay, now header lines to skip, it is asking some values, so we need to see the file first. View file. When you view the file, you can see here how many lines here, like how many header lines are there from which the value starts. Let's start from here. Okay, 1 2 3 4 5 6 7 8. Here after browsing and viewing the file, here we need to skip 9 lines. Okay, so header lines to skip are 9. After the 9 lines, the main data starts actually. So the number of points per line, we can keep it as 1. Okay, fixed format, characters are 10. Okay, this is all defined. Example time history data. Okay, now define load cases. We are not doing a response spectrum one, so we can delete this case. add new case, time history. Okay, time history, go for time history, add acceleration function. This is it, example time history. Scale factor, the one which we have calculated, that is Ig by 2r. The value is coming out to be 1663.5. Okay, and this is carried out in only one direction, that is in EQX. Hence we keep it in only in the one direction, that is U1. Okay, now the analysis, that is assigning of time history load case is done. Now log the model, analyze, set load cases to run. So we can ignore dead as well as live load as it takes more time. We can go for SEISMIC as well as time history. Okay, we can run this structure. And check whether all the members are passing. Okay, 16 concrete frames are failing, so we need to reiterate it, so that which will analyze once again and run the analysis once again. You can check now. How many members are passing, how many members are failing. Okay, now we can go for design, concrete frame design, verify all members. Okay, it has passed all the members now. So again we can display combined story response plots. We can check here to check displacement, check the load case as time history. Then we can go for animate if we want to see the displacements. See, you can see here. at a particular time period, how the response takes place. You can see here share values. You can increase the speed, you get such values. Okay, then when we go to reports, we can get the summary report. You can check here everything whichever we want. The sections which we have used, you can get it from the summary report. You can print if you want, as it is a cracked version.